And here we go. Unit 2, moving on, lesson 13. Actually, this is lesson 12, sorry. This number is from last year. So we are on lesson 12. So we are getting into our triangle proofs. We've done side angle side as a reason why triangles can be congruent. That means I can map one triangle on top of another triangle without doing any physical measurement of angles or side lengths. But if we can use our construction techniques to map one triangle onto another triangle, then those two triangles are congruent. So let's take a look at some information here. Let's pretend that we're given this diagram and we are told that AB is equal to RS. So that means AB and RS are the same length. And AB is also parallel to RS. So that means that AB here is parallel to RS here. Now, parallel lines have nothing to do with lengths, so this is just coincidence that they gave us information that tells us that AB is congruent to RS, and coincidentally, AB is parallel to RS. So what pair of angles can we get because the lines are parallel? Parallel lines lead to information about angle measures. Which angles would be congruent if AB is parallel to RS? It would be angle S and angle ABC. Now, angle S, we can use a single letter to name that angle because there is only one angle inside the triangle at point S. But at angle B, at point B, if I just say B, I don't know which side I'm referring to. So I have to use three letters here and describe it as angle ABC, just to make sure that the reader knows which angle at vertex B I am referring to. If we wanted to do side angle side, what other side would we need? What other piece of information would we need to make these triangles congruent by side angle side? Right, we would need TS from that triangle to be congruent to CB from that triangle. So we would need another pair of congruent sides, and then we could do side angle side. So let's pretend we know those two sides are congruent, and let's pretend that we have two pairs of congruent triangles, or one pair of congruent triangles, two congruent triangles. If we pretend that we have that, now we know that those two triangles are congruent. Name one other pair of congruent sides. We were told at the beginning that AB is congruent to RS. What's another pair of equal sides? So we could say AC is equal to RT. All right, so if we know side angle side and the triangles are congruent, that means we can start to pair up the other parts of the triangle that were not mentioned in our proof or in our statements. So now that we know that, what are the other two pairs of congruent angles? So far, the only pair of congruent angles we have is angle S congruent to angle ABC. But if those two triangles are congruent, I can put one triangle on top of the other and match up the other pairs of corresponding angles. And those would be angle RA and angle C and RTB. Remember, if there's more than one angle at a particular point, you will use three letters to name that angle. Angle C is obvious. Angle A is obvious. Angle R is obvious. But at point T, I could have angle RTC or RTA. Or RTB, I mean, RTB. And my letters covered up. RTB. Make sure you're using the three letters so the reader knows exactly which angle you are referring to. When we match up those corresponding parts after the triangles are proven congruent, the reason we use in our proof is corresponding parts of congruent triangles are congruent. When you're proving two triangles congruent, you are allowed to say that all of the non-mentioned corresponding parts, the other pieces that you didn't prove in your proof, those other pieces are also congruent because the corresponding parts of congruent triangles are congruent to each other. If we write it as an if-then statement, if the triangles are congruent, then all pairs of corresponding angles and all pairs of corresponding sides are also congruent. It all goes back to our constructions, and if we have a rigid motion that maps one triangle on top of another triangle, all the side lengths and angle measures remain the same, so the triangles are congruent. We say congruent because we're not measuring anything. We are showing that one fits on top of the other and all the pieces match up. That's the idea behind congruence. Eventually, once you show me that you have memorized what corresponding parts of congruent triangles stands for, corresponding parts of congruent triangles are congruent, we can abbreviate it using CPCTC, and that's what you'll use. You can only use CPCTC in a proof after you have proven the triangles congruent, because it stands for corresponding parts of congruent triangles. If you don't have congruent triangles, then you don't have corresponding parts of congruent triangles. So you need to prove the triangles are congruent first, then you can use this. So let's practice. And as we're doing it, maybe we can talk about some special things about an isosceles triangle. So, isosceles triangle ABC is given. There we go. We have an isosceles triangle. We know that an isosceles triangle has at least two congruent sides. We say at least because technically an equilateral triangle is isosceles because it has two congruent sides. So an isosceles triangle has at least two congruent sides. We're going to prove that the base angles of an isosceles triangle are congruent. We've been assuming and going under the knowledge that the base angles of an isosceles triangle are congruent. Now we get to prove it. All proofs start with the same thing, and that is given information. So take the time to write down your given information, please. We have isosceles triangle ABC, where AB is congruent. Segment AB is congruent to segment AC. And AD bisects angle BAC. But to complete this proof, we must draw in that auxiliary segment AD. And we are going to draw AD such that it is the angle bisector of angle A, and D is the intersection on point BC. So that's the segment that you saw me erase a few minutes ago. So I'm going to draw in this segment, and that is D. And we are drawing it in to be an angle bisector. So now let's go through our proof. We are supposed to prove that angle B and angle C are congruent. So we are trying to prove that the base angles of an isosceles triangle are congruent. So what do you see? What do you know? Well, the first thing we have to do, we should write into our proof that we did an auxiliary line segment. We drew in the auxiliary line that's in the given as an angle bisector. But we have to say in the proof that we put in an auxiliary line. Once we have that auxiliary line taken care of, because it was drawn in as an angle bisector, a bisector creates two congruent parts. Angle BAD is congruent to angle CAD because bisector creates two congruent parts. In this case, our two congruent parts are two congruent angles. What else do we know? Well, we know that AD is congruent to itself. That's the reflexive property. So we're going to mark that with two dashes, two congruence markings. And that side allows us to say that the two halves of my isosceles triangle, those two triangles are congruent by side angle side. Once the two triangles are congruent by side angle side, we can get to what we were asked to prove in the first place. Our proof asks us to prove that the base angles of an isosceles triangle are congruent. That means prove that angle B is congruent to angle C. Since these two triangles are congruent by side angle side, even though they weren't mentioned in the proof yet, if the two triangles are congruent, I can put one on top of the other and match up all the corresponding parts. So the piece that's left for our proof is to match up angle B congruent to angle C, because corresponding parts of congruent triangles are congruent. Once the triangles are congruent, then I can match up any of the parts that I have not mentioned yet in our proof. The reason why? Corresponding parts of congruent triangles are congruent. We could do the same kind of proof if we started with the base angles congruent, then we could prove the sides congruent by doing the same similar kind of proof. So that means that in an isosceles triangle, if two sides are equal, then the angles opposite those sides are equal. The opposite of that, if two angles are equal, the sides opposite those two angles are equal. Now, this all has to be within the same triangle. And those two statements give us our next two theorems. If you recognize isosceles triangles in a proof, we can use that information in a couple different ways. If we know the sides of a triangle are congruent, then we can conclude that the opposite angles are congruent. So if we were given the sides first, we can say the sides create equal angles opposite those equal sides. This is called the isosceles triangle theorem. The isosceles triangle theorem says that if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. In a quick diagram, because sometimes visualization helps. If I start with two sides congruent, my conclusion is opposite angles are also congruent. The converse of that, change the order of that theorem, says if we know the angles to start with, if the angles of a triangle are given congruent, then the conclusion we can make is the opposite sides are congruent. This is similar information but written in a different order. This time we would start with two congruent angles, and by the converse isosceles triangle theorem, we could say that the sides are then equal after that. So it all depends on what you're given or what you know first as to which theorem you should use. You have to keep them straight. Make sure you use the right one in the right places. So let's give her a shot. Given triangle ABC is congruent to, given angle ABC is congruent to angle ACB, and AX bisects angle BAC. So first thing we do, write in our givens. With triangle ABC congruent to ACB, I want to make sure I mark the correct angle in my figure. ABC is this whole big angle, and ACB is the big angle down here as well. AX bisects angle BAC, so that's the angle at the top cut in half. So we are supposed to prove that, let's see, let me get to here. We want to prove that triangle ABX is congruent to triangle ACX. Those are the two triangles we are trying to get congruent. So we have to take what information we have based on what things we can say according to the diagram and what we see, and we're going to get those two triangles congruent. So we have a bisector. Why don't we go ahead and use that first? We know that a bisector creates two congruent parts. So our angle bisector will create two congruent angles. So that's angle BAX is congruent to angle CAX because a bisector creates two congruent parts. So we are on our way. Next, AB is congruent to AC. Why is that? Well, here's why it is that. Triangle ABC, the whole big diagram, has angle ABC congruent to ACB. That means it's one big giant isosceles triangle surrounding my whole diagram. According to the theorems that we just talked about, I just talked about, you just listened about, on the previous page, or actually right above this proof on your paper, if a triangle has two equal angles, then the sides opposite those angles are also equal. That was the converse isosceles triangle theorem. Right? No, there it is. Converse isosceles triangle theorem. So we will get AB congruent to AC by the converse isosceles triangle theorem. That puts this side congruent to that side. And then the reflexive property with AX congruent to itself gives us side, angle, side, and we are all sorts of set with that. So what rigid motion? If these two triangles are indeed congruent, what rigid motion puts one on top of the other? Well, we would just do a simple reflection across segment AX. Doesn't matter which one you reflect, because whichever one you reflect onto the other one, it'll match up all the corresponding sides and all the corresponding angles. Next proof. We are given that JK is equal to JL, and JR bisects KL. First things first, write in your givens. Pause this as you need, but I'm going to keep cruising. So next, what do we know? Well, we know that JR bisects KL, and read carefully because this is a segment that's been bisected, not an angle. So we have to make sure we use the bisector information correctly. So since JR bisects segment KL, that puts KR congruent to LR on the bottom of our diagram. What else do we know? Well, I should have marked these at the beginning, but we have JK congruent to JL. We need some more information. So let's refer back to our big triangle. What kind of a triangle is that has two equal sides? And what do we know about that kind of a triangle? So that gives us angle K congruent to angle L, because they would be the base angles of an isosceles triangle. The theorem, isosceles triangle theorem, says if two sides of the same triangle are congruent, then the angles opposite those sides are also congruent. That gives us the angle we need to say that the two triangles are congruent by side angle side. And once we have the triangles congruent, we can match up any of the remaining corresponding parts and say that those are also congruent, which finishes our proof. Angle JRK congruent to angle JRL, because corresponding parts of congruent triangles are congruent. Which brings us to our final proof before you go off on your own, I think. All right, so this one, we have JX equal to JY and KX equal to LY. That is our given information that we start with. JX, that side there, JY over there, and then KX down here, that little piece at the bottom, is equal to YL, that little piece at the bottom. We need to prove that JXK is congruent to triangle JYL. So JXK is that little one over here on this side. And then JYL is the one over here on this side. So we have to prove those two triangles are congruent based on what we see and based on the given, based on the given, right? So what else do we know? What's next? Well, angle 1 is congruent to angle 2. The triangle JXY right in the middle here, that is an isosceles triangle with two equal sides. If two sides of the same triangle are congruent, then the angles opposite those are also congruent. That was our isosceles triangle theorem. It's isosceles. So angle 1 is congruent to angle 2. Now we're going to go back to unit 1 and use some of that information. Look at angles 1 and 3. What type of angles are 1 and 3? Look at angles 2 and 4. What types of angles are 2 and 4? So you could have said they are supplementary. You could have said they add up to 180. Those two descriptions mean the same thing. If two angles are supplementary, that means those two angles add up to 180. But what types of angles are they? Why are they supplementary? Why do they add to 180? If you say that they are supplementary because they add to 180, that's not a reason why. You're saying they add up to 180 because they add up to 180. The definition of supplementary is they add up to 180. That's not a reason why they add up to 180. The reason why they add up to 180 is because they're linear pairs, and linear pairs are supplementary. Now, the reason why I'm using the word supplementary instead of the equations add up to 180 is so I can use the congruent supplements theorem to say that angle 3 is equal to angle 4. If two angles are supplementary to the same angle, or in this case, they are supplementary to congruent angles, then they have to be equal to each other. So that conveniently gets us angle 3 congruent to angle 4. 3 congruent to angle 4. Now, if you look at my diagram closely and what I have labeled, I have these triangles congruent by side, angle, side. So we're all set with that portion of our proof. But I'm also supposed to prove that the big triangle, JKL, is isosceles. So once I have the smaller triangles congruent, I can line up or match up side JK with side JL because those are corresponding parts of the triangles that we just proved congruent. And if the triangles are congruent, that means corresponding parts of congruent triangles are congruent. CPCTC, corresponding parts of congruent triangles are congruent. The first word is corresponding. It matches up the sides or angles. Corresponding parts of congruent triangles are congruent. Now, we're supposed to prove that this triangle, this big triangle JKL, is isosceles. We just proved that it has two sides the same. Our proof is not done until I actually say in my proof that it is isosceles, because isosceles triangle has two congruent sides. So make sure when you're asked to prove it's isosceles, that's how you end your proof, saying that it's isosceles. All right, so that brings us to the end, just over 20 minutes. Peace out, be good, be safe, see you soon.